So far in the previous videos, we've been focusing on sketching both the parent function, the transformations from the parent functions of x squared to something else, and of the square root of x to something else. But now we're actually going to put into some use, and what we're going to investigate now is the domain and ranges. So this is the domain and range of inverse functions. All right, and this is a very important unit. So let's start with example 1. Okay, so in example 1, I give you a function. Okay, and here's the function, which is -3, and it's going to be 10 minus 5x, and I'm going to put a nice big old square root around it, and I'm going to write plus 1. Okay, and so question A is find the domain and range of f of x. So if you recall, whenever I've asked you to find the domain and range of some function, it's best to draw it out. Okay? And when we have a function like this, the first thing we should probably do is factor what's on the inside. Because if we don't factor, we'll have no idea of what it will look like. So when I factor this, so f of x is equal to -3. What I'm going to do is I'm going to factor out the -5 because that's the coefficient of x. So -5, it's going to be x minus 2, and then I'm going to put a good old square root around it and plus 1. Okay? And I'm a little experienced with this, so what I'm going to do is I'm just going to sketch the graph right away. But I'll tell you my secret. My secret is this. Here's how I sketch it really fast. Is first, let me just draw some axes. So I'm just going to draw some axes right here. The thing is that the factored form gives you so much information. So because there's a negative on the outside and a negative on the inside, it means that's reflected both across the x and the y axes. I don't really, if I'm drawing a rough sketch, because I'm drawing a rough sketch, I really don't need to worry about the vertical stretch or even the horizontal stretch because they don't really change the direction. All they do is basically squeeze all the x's or multiply all the x's, and same with the y's, but they don't change the direction. And then after that, I already know that it's 2 to the right and 1 up. So since I already know that, it's basically 2 to the right and 1 up. So here's my starting point, and since there's a reflection across the x and y, it's going to end up like this. Okay, so that's basically the square root function. Again, it's a rough sketch. I really don't care. All I need to know is the domain and range, so all I care about is the rough sketch. So again, the domain of this function is x's element of reals, so we can see clearly that x is less than or equal to 1. And the range of this function is y is element of reals. That's an e. And we can say y, oops, actually I made a small error here. It's not x is less than 1, it's x is less than 2. I wasn't paying attention. So here, this is 2, and that should be 2. Anyways, for y, it should be y is less than or equal to 1, and that's the domain and range of f of x. Now, let's do part B. So part B says, part B says find the domain and range of f inverse of x. All right? And since we have the domain and range of the function, we can easily find the domain and range of the inverse. Remember, the domain of a function is the range of the inverse, and vice versa. So if we go here, the domain of this function is x's element of reals. I'm going to use the range of that function to help me get that. So it's simply x is less than or equal to 1. And the range is y is element of reals. If I scroll just a little bit further up, I can see that since x is less than or equal to 2, this will be y is less than or equal to 2. And I'm done with this question. Now part C is the question that I really want to focus on. So C is this. Find f inverse of x. All right, so find f inverse of x. So let's do this. So our original function is f of x is equal to, let me get here, and it's this one, and I could take either one. I'm actually going to start with my factored form. I just like it better. So I'm going to start with my factored form, so -3 and all that stuff. So it's -3, -5, x minus 2, and then the square root around it, and plus 1. Right? So first, just write this is equal to y. So -3, -5, x minus 2, square root of that, plus 1. If we're finding the inverse, the first thing we have to do is switch x and y. And so x is equal to -3, -5, y minus 2, square root, plus 1. And now we just literally have to rearrange this so we can solve for y. So this is x minus 1 is equal to -3, square root of -5, y minus 2. We're going to divide by -3. And when we divide by -3, really what we're doing is just on this side, it'll end up being a -1/3. -1/3 is because when you divide, it becomes the denominator. So it'll become -1/3. X minus 1 is equal to the square root of -5, y minus 2. So in order to get rid of the square root, oh, sorry, what have I done? There's no square here. Apologies, there's no square there. Okay, so I jumped the gun. So then what we're going to do next is we're going to square both sides. So if I square both sides, what happens next is basically this will become this 1/3. When I square that, becomes 1/9. And then this x minus 1 becomes x minus 1 squared, which is equal to -5 y minus 2. And then the next thing I'm going to do is I'm going to divide by -5. And when I divide by -5, it's going to multiply by the denominator there. So 9 times -5 is -45. So it's -1/45. And it's x minus 1 squared is equal to y minus 2. And my last thing is basically I just have to solve for y. So y is equal to -1/45 x minus 1 squared plus 2. And if you've observed anything, so this is basically the inverse, and if you've observed anything, this is actually a quadratic function. So what's really interesting to note is that the inverse of a square root function is actually a quadratic function. And actually, it also works the other way around. The inverse of quadratic functions are actually square root functions. And we'll get to that in a later example. But first, the thing I want to highlight is that the inverse of a square root function ends up being a quadratic function. But this is not it. This is not our final step. Our final step is this, all right? Which is we need to look at the domain and range. So we might think that the entire quadratic applies here, but it actually doesn't. Let's say we draw the entire quadratic. So if we draw this entire quadratic, right? If I draw a rough sketch, I know it's to the right by 1, and then up 2, and then so here's my vertex, and this is going to go down. So basically, it's going to face down like this. But remember, we already found the domain and range of the of our inverse function. So let's look at the domain and range. See, it says over here, find the domain and range of the inverse function, and it says x has to be less than 1. So if x has to be less than 1, if I go back to this diagram right here, well, here's 1, and if x has to be less or equal to 1, it means I have to erase everything to the right. So I have to erase everything here to the right. So this is when the domain and range becomes so important. You need to pay careful attention to the domain and range. So in other words, my final answer is going to be f inverse of x, okay, is not this. It is partially this. It is -1/45 x minus 1 squared plus 2, but I'm going to add a domain restriction, which is x is less than or equal to 1. Without this domain restriction, you're saying that the entire thing exists. But as we've determined, once again, with question part B, the entire thing does not exist. It's only x is less than 1 exists. So it's very, very important to add a domain restriction when it's necessary. All right, I'll see you in the next video.